Well, I've got a real special treat for you tonight. We're going to focus specifically on some AP review questions and looking at some actual questions that showed up on past AP exams as they pertain to material we've already covered. Specifically, we're going to choose the theme of looking at graphs or problems where they've given us the graph of f prime, and then using that image, we're going to see how much we can tell you about f and f double prime and so forth. So as we chase that elusive dream of grabbing that score of a 5, let's go ahead and get started and look at some past AP questions. So our first question comes to you from the 2000 AP exam, and I think you're going to find this question quite a pleasant one. But just to keep emphasizing here, we are staring at a graph of f prime, and that's something we're going to have to keep reminding ourselves that we're not looking at a picture of f. We're definitely looking at a picture of f prime. And so I think the sign charts can be our best friends. And so I'm going to go ahead and I'm going to find all my critical points. And my critical points are anytime the f prime equals 0 or anytime f prime doesn't exist or is undefined. So I've got a critical point at -5, I've got one at -1, and I've also got one at +5. And those are all zeros for f prime, and I don't think there's any moments where f prime doesn't exist. So anyway, f prime, I've got a bunch of positive values in here, and then from -5 to -1 we've got a bunch of negative values, and then we've got a whole bunch of positives, and even though 5 was a critical point, they stayed positives afterwards. So what do we know about f? We know f's increasing, we know f's then decreasing, and then f does a whole lot of increasing. So let's see if we can go ahead and answer those first couple of questions. When does f attain a relative min? So I'm going to jump all over -1 right here, and I'm going to say f has a relative min at x equals -1 because f prime changed from, you guessed it, negative to positive. And then the second part B there piggybacks right off of that. When does f attain a relative max? I'm going to say f's got a relative max at -5 because f prime changed from positive to negative. Now, just a quick reminder that these relative maxes and mins, or sometimes we'll see the vocabulary, they'll call it local maxes and mins, those can only occur at interior points. The endpoints are not candidates for those relative extremas. So right off the bat, you know, you're probably like 30 seconds into the question, you've already nailed A and B, and you're feeling really good about yourself here. So let's go ahead and see if we can wrestle down C here. We're now going to try to construct a sign chart for f double prime just by reading the graph of f prime. So just recall that the slopes of f prime are going to be f double prime's values. So let's see, all of these slopes are negative, and then right there at -3 we've got a critical point. Okay, and then all these slopes are positive until we hit +2. And then we've got, now here's the interesting one. Do you see how they said there was a vertical tangent line at x equals 3? Okay, what we're saying is that the second derivative doesn't exist at that moment, okay? Because the slope doesn't exist, so f double prime doesn't exist. So we actually have to list 3 as a critical point, and then 5 will be a critical point because the slope is 0. And so let's go ahead and fill in our signs. F double prime, we said all of those slopes were negative. So let's go ahead and list a bunch of negatives. That tells us that f itself is concave down. Let's see, then from -3 all the way to +2, we've got a bunch of positive slopes, so f's concave up. Now, here's where it gets interesting. From 2 to 3 we've got negative, and then from 3 to 5 we've got negative. So it seems like we should be able to just do one interval, but you're going to find out shortly that we can't. And then from 5 onward, we've got a bunch of positive slopes. So we're concave down, and then we finish concave up. So the ultimate question is, when is the second derivative negative? Well, I'm going to say, and I can't say negative infinity to -3. I've got to say -7 to -3, union. I'm going to go from 2 to 3, union 3 to 5. All right, and just simply, all I'm going to say is that the slopes of f prime are negative within those intervals. Notice how I couldn't just say 2 to 5, because if I just said 2 to 5, then that would include the 3, and I don't want to include the 3 within that interval. Now our last question tonight, the absolute max, is probably the trickiest one. And until we've officially covered the topic of integrals and how an integral measures the area underneath a curve, this one's going to kind of be a little tricky, but I think we could still fight our way through it. So think about what f's been doing. Okay, f's done some increasing, and then f did some decreasing, And then from -1 onward, f just did a whole boatload of increasing. And at our very first Good Morning Math, we did cover the idea that the area underneath the curve tells you exactly how much increasing or decreasing. So this area tells you the amount of increasing, this area tells you the amount of decreasing. And just kind of giving it the eyeball test, those areas are roughly equivalent, so they kind of offset each other. And then we just do a whole lot of increasing. So just kind of using our common sense test here, it's telling me that the absolute max is at x equals 7, otherwise the right endpoint. So just kind of give us a visual image of what f's doing. It feels like, let's see here, f is starting, wherever he starts at -7. I'm not sure how high it is, but it's going to do some increasing up until -5, and then from -5 to -1, we're going to do some decreasing and kind of, get back to about where I started approximately. And then from -1 onwards, whoops, I should have kind of rounded that the other way, I guess. And then from -1 onwards, we're just going to take off and just really, get real tall, and our absolute max will be at x equals 7. Our second AP question might even be shorter and snappier than the last one. The first thing that jumps out at me here is, again, continuously remind yourself we're staring at f prime, not f. They wanted points of inflection, and as soon as they said points of inflection, I started thinking about the second derivative, and I started challenging myself and wondering, can I create a sign chart for the second derivative? So I went ahead and I asked myself, okay, when's the second derivative equal to 0? And again, I'm reading the slopes of this picture, and I've got a slope of 0 right there and right there, so I'm going to say x equals 1 is a critical point, and x equals 3 is a critical point. And just to be safe, I asked myself, is there ever a moment when the second derivative is undefined? And luckily we said no, so these are the only two critical points. Now all of those slopes right in this interval from x equals -1 until x equals +1, all those slopes are positive, and implying that f's concave up. And then we had from x equals 1 until x equals 3, we had a whole bunch of negative slopes. So f's concave down. And then from x equals 3 until x equals 5, we've got a whole bunch of positive slopes, meaning f's concave up. So what do we got here? And again, we've got to focus on the reason and justifying our answer. We're going to say that f has a point of inflection at x equals 1 and x equals 3 because f double prime changed signs. Alright, now we're on to part B. At what value of x does f attain its absolute minimum value, and then where does it attain its absolute maximum value? Okay, so let's think about the sign chart that we might have generated for the first derivative. For the first derivative, I would have said, we've got critical points at x equals 1 and x equals 4. That's when the first derivative is equal to 0. And again, there's never a moment where the first derivative is undefined because the picture I'm staring at is continuous. So we've got 1 and 4. Now, as far as this picture goes, I've got a bunch of negative values right in here, and then they continue to stay negative until I hit 4. So even though 1 was a critical point, it turned out to be what I call a false critical point because they yielded neither a relative max nor a relative min. So we know that f's doing some decreasing, and then some more decreasing, and then finally a little bit of increasing at the end. So here's what's happening. Alright, f's doing a lot of decreasing, and then a whole lot more decreasing. And then at the very, very end, it's doing a dab of increasing. So if you could try to visualize this picture, what have we got? What have we created? We've created a graph that is decreasing, has a horizontal tangent line at x equals 1, continues to decrease, and then once it hits its min at x equals 4, it turns around and increases a little bit, but not enough to catch up and counteract or counterbalance all the decreasing we did. So I'm going to say the absolute min occurs at the left endpoint, which is x equals -1. Whoops, I'm sorry, I screwed that up. That would be the max. Alright, and then where's the absolute min? The absolute min occurs at, in this case, the relative min, which is at x equals 4. So there's the two absolutes. Again, once we officially cover the integrals and how the integral measures the area underneath the curve, we'll have a more sophisticated justification perhaps. Alright, now for part C, and I think you're really going to enjoy this part. We want to write the equation of a tangent line to the graph of g. Now g was defined as the product of h and f of x, and we want to do the tangent line at x equals 2. So right away we can calculate g of 2, right? G of 2 is simply going to be substitute a 2, and you'll get 2 times f of 2. And in the stem up here in the question, this part's called the stem. That's going to be 2 times 6, which gives us a y-coordinate of 12. The next thing I want to try to find is g prime of x. And remember, it's the product of x and f of x. So you're just screaming product rule on this one. First times the derivative of the second plus the second times the derivative of the first. And now I'm going to substitute a 2 into all those x's. I've got 2 times f prime of 2 plus f of 2. Now f prime of 2 is a value that we're going to read off the graph. And let's see, what do we got here? Right there, f prime of 2 is equal to negative 1. So I'm going to substitute my negative 1 in there. And f of 2, again, was just a 6. So I ended up getting 4 for my slope. And if I put all those components together, I've got y minus 12 equals slope of 4 times the quantity x minus 2. And ladies and gentlemen, there's this equation for my tangent line to the graph of g at x equals 2. Well, we're really flying through these old AP questions, and we're making them look pretty easy, and we're gobbling up our maximum 9 points for a perfect score on each of these. And we're going to finish with one more here tonight, and just continuing with the theme, they've given us the graph of f prime. So we're staring at the first derivative, and as soon as I see them even, mention the phrase relative max, I'm already thinking sign chart for that first derivative. I'm setting the first derivative equal to 0, which occurs at, negative 5, which is an endpoint. Negative 3, positive 1, and positive 4 are going to be my critical points. So let's see what we got cooking here. And anytime the first derivative is above the x-axis, we would call those positive values. And then we have a bunch of negatives. And then from 1 to 4, we're positive again. And from 4 to 5, we got a couple of negatives. So we know that f's increasing, we know that f's decreasing, and then increasing, and then decreasing. And we would say there's relative max at x equals negative 3 and at x equals 4 because f prime changed from positive to negative. Feels like we've uttered that phrase about 13 million times the last couple of weeks. All right, now, can we tackle part B, where can we figure out where f has a point of inflection? Again, point of inflection, now you're screaming second derivative. When will the second derivative be equal to 0? Again, reminder, the slopes of f prime will tell you what the values of f double prime are. So we're saying the f double prime is equal to 0 at negative 4, at negative 1, at positive 2, and those will be my 3 critical points. Now, technically, we have a non-differentiable point at 1, and I probably should include it on my sign chart, but the slopes aren't going to change signs at that moment, so we should be okay. But anyway, let's go negative 4. Let's go negative 1. Remember, we're describing the x values. I'm going to throw a 1 on there just to be safe. We'll throw the 2 on there. And again, we're reading slopes. So if you see positive slopes right in here, we're thinking positive values for the second derivative. And then we've got a bunch of negative slopes. From negative 1 to positive 1, we're positive. And from 1 to 2, we're positive. And from 2 all the way to x equals 5, we got a bunch of negative slopes. So I've confirmed that there are points of inflection at x equals negative 4, x equals negative 1, and x equals 2 because f double prime changed signs, or the slope of f prime changed signs, something of that nature. You could even go as far to say that f prime changed from increasing to decreasing and vice versa. That would also be an acceptable answer. But why make it more complicated than it has to be? I just like to keep it simple. Always stick with the phrase f double prime change signs and you'll be in good shape. Now as far as point C, we want to know when f's concave up and when it has a positive slope. So concave up means that the second derivative's got to be positive. And of course a positive slope means the first derivative's got to be positive. So I've just got this 2 sign chart stacked on top of each other. I've got the x values appropriately placed, and I'm looking for double positives. So I would say from negative 5 to negative 4, they're both positive. Let's see, when else are they both positive? How about from 1 to 2? I'm thinking from x equals 1 until x equals 2, they're both positive. So I would say those are the 2 intervals, and I would just justify that by saying, both f double prime and f prime are positive within those intervals. Last but not least, we've seen this common theme also. The question that's always incorporated with these relative extremas and points of inflection is the idea of finding an absolute min. Now, we're not going to worry about the value per se, at least today anyway. I'm just going to try to guesstimate or estimate where it is. And so you'll notice that this function f has done, some increasing, but then quite a bit of decreasing. It certainly outweighed and went beyond the amount of increasing it did. Then we increased again, and then we decreased a tad bit at the end. So I'm interested to see your thoughts. I want to see, so let's finish up our notebook by making a prediction as to where we think the absolute minimum value would occur. And it'll be interesting to see your thoughts and how confident you feel on this particular question. So good luck, and we'll catch you tomorrow.